Lesson 2.3, Solving Absolute Value Inequalities. What are two ways to solve an absolute value inequality? Algebraically and graphically. So we'll see. Algebraically or graphically. Graphically. All right, those are the two ways. Visualizing the solution set of an absolute value inequality. You know that when solving an absolute value equation, it's possible to get two solutions. Here you will explore what happens when you solve absolute value inequalities. Determine whether each of the integers from -5 to 5 is a solution of the inequality, the absolute value of x plus 2 is less than 5. Write yes or no for each number. Okay, so how can we do this? Well, we can put -5 in there. -5, the absolute value of -5 is 5, and then 5 plus 2 is 7, so that would be a no. All right, -4. The absolute value of -4 is 4. 4 plus 2 is 6. That is not less than 5, so that's no. What if we put -3 in here? The absolute value of -3 is 3. 3 plus 2 is 5. That is not less than 5, so that is no. -2, the absolute value of -2 is 2. 2 plus 2 is 4, so yes. Yes. 1, -1, absolute value of -1 is 1. 1 plus 2 is 3, which is less than 5, so that's yes. 0, let's see, -2, -1 are solutions. 0, well, the absolute value of 0 is 0. 0 plus 2 is 2. That is a yes. So 0 works. What about 1? Absolute value of 1 is 1. 1 plus 2 is 2. 1 plus 2 is 3, and 3 is less than 5, so yes to 1. 2, the absolute value of 2 is 2. 2 plus 2 is 4, and 4 is less than 5, so we have yes. 3, the absolute value of 3 is 3. 3 plus 2 is 5, which is not, so that's no. So if 3 is not, then 4 is not, and 5 is not. So there you go. B, determine whether each integer from -5 to 5 is the solution of the inequality. The absolute value of x plus 2 is greater than 5. Okay, so what's the difference between A and B? Well, A was less than and B is greater than. All right, so we're going to do the same thing we did a minute ago. -5. The absolute value of -5 is 5. 5 plus 2 is greater than 5. So that is a yes. That is a yes. -5 works. We'll try -4. -4, the absolute value of -4 is 4. 4 plus 2 is 6, which is greater than 5. So we got yes. 3, -3. -3, the absolute value of -3 is 3. 3 plus 2 is 5. 5. Is 5 greater than 5? No. All right. So 4, the absolute value, well, -2, the absolute value of -2 is 2. 2 plus 2 is 4. Is 4 greater than 5? No. 1 at -1, that would be 1 plus 2 is 3. That's no. 0, the absolute value of 0 is 0. 0 plus 2 is 2. No. 1, well, the absolute value of 1 is 1. 1 plus 2 is 3. That is not. So that's no. 2, the absolute value of 2 is 2. 2 plus 2 is 4. It is not greater, so that's no. 3, absolute value of 3 is 3. 3 plus 2 is 5. 5 is not greater than 5, so that is no. 4, absolute value of 4 is 4. 4 plus 2 is 6. So that is a yes. 6 is greater than 5. So 5 is greater than 5. Or absolute value of 5 is 5 plus 2 is 7. 7 is greater than 5. So that's a yes. All right, good. Good. State the solutions of the equation, the absolute value of x plus 2 equals 5, and then relate them to the solutions in the inequalities for steps A and B. The solutions for the absolute value of 5, or the absolute value of x plus 2 equals 5. Well, let's see. The absolute value of x plus 2 equals 5. So we're going to subtract 2 from both sides, and we got 3. So x will equal -3, or x will equal 3. So the solutions are -3 and 3. These are the only numbers that are not solutions. If you look back here, nope, not there, and nope, not there. Those are the only numbers that were not solutions of either inequality. They are the only numbers that are not solutions of the inequalities absolute value of x plus 2 is less than 5, and the absolute value of x plus 2 is greater than 5. They're not solutions to either one. Why? Well, there was no or equal to. Okay? All right. If x is any real number and not just an integer, graph the solution of the absolute value of x plus 2 is less than 5, and the absolute value of x plus 2 is greater than 5. So if it's less than 5, how would we graph that? Well, the absolute value of x plus 2 is less than 5. So we got the absolute value of x plus 2 is less than 5. Subtract 2 from both sides, and you got less than 3. So you got x is less than 3, or its opposite, x is greater than -3. So let's find -3, and it's not or equal to, so it's open parentheses, and 3 is, and then connect them. All right, there you go. There's your solution. Now, and so we'll do the graph of x plus. So we're going to subtract 3 from both sides, so we get the absolute value of x is greater than 3. So x is greater than 3, or x is less than -3. It's opposites. So here's -3, here's 3, and it's going to go to the outside. Okay, so x is less than -3, or x is greater than 3. This is an or, and this is an and. It satisfies both conditions. This satisfies one or the other. Reflect. It's possible to describe the solutions of the absolute value of x plus 2 is less than 5, and the absolute value of x plus 2 is greater than 5 using inequalities that don't involve absolute value. For instance, you can write the solutions of the absolute value of x plus 2 is less than 5 as x is greater than -3, or x is less than 3, or excuse me, and that said and x is less than 3. Notice that the word and is used because x must be both greater than -3 and less than 3. How would you write the solution of absolute value of x plus 2 is greater than 5? Explain. So the absolute value of x plus 2 is greater than 5. We would write it as x is less than -3, or x is greater than 3. And we're going to use the word or because x must be either less than -3 or greater than 3, but not both. So we use the word or. Okay, it satisfies one of those conditions. Describe the solutions of the absolute value of x plus 2 is less than or equal to 5, and the absolute value of x plus 2 is greater than or equal to 5. Using inequalities that don't involve absolute value. So let's see, if we got the absolute value of x plus 2 is less than or equal to 5, we're going to say x is greater than or equal to -3, and x is less than or equal to 3. If we have the absolute value of x plus 2 is greater than or equal to 5, we're going to say x is less than or equal to -3, or x is greater than or equal to 3. Solving absolute value inequalities graphically. You can use a graph to solve an absolute value inequality of the form f of x is greater than g of x, or f of x is less than g of x, where f of x is an absolute value function and g of x is a constant function. Graph each function separately on the same coordinate plane and determine the intervals on the x-axis where one graph lies above or below the other. For f of x is greater than g of x, you want to find the values for which the graph of f of x is above the graph of g of x. For f of x is less than g of x, you want to find the x values for which the graph of f of x is below the graph of g of x. Number 1, example 1, solve the inequality. Let me go through this one with you. The absolute value of x plus 3 plus 1 is greater than 4. The inequality is of the form f of x is greater than g of x. So determine the intervals on the x-axis for which the graph of f of x lies above the graph of g of x. F of x lies above the graph of g of x. The graph of f of x lies above the graph of g of x equals to the left of -6, and to the right of x equals 0. So the solution is x is less than 6, -6, or greater than 0. B. Let's see. The inequality is the form of f of x is less than g of x. So determine the intervals on the x-axis where the graph of f of x equals the absolute value of x minus 2 minus 3 lies below the graph of g of x equals 1. The graph of f of x equals the absolute value of x minus 2 minus 3 lies below the graph of g of x equals 1 between x equals -2 and x equals 6. So the solutions of the absolute value of x minus 2 minus 3 is less than 1 is x is greater than -2 and x is less than 6. And I probably need to graph it real quick. So we got 2, -3, 1, 2, 3. That's right there. Okay. And let's give it some legs here. There we go. And there's that. And here is, I wish that would have not gone, stopped right there. Let's see. And we'll put that right there. And then let's graph, and that is f of x right here. Let's do g of x. G of x is just 1. It's a flat line 1 right there. So it is talking about is greater than -2. So that's going to be from right here. And that's going to be from right there at 6. X greater than -2 and less than 6. So it's going to be right there. All right. Suppose the inequality in graph in part A is the absolute value of x plus 3 plus 1 is greater than or equal to 4, instead of the absolute value of x plus 3 plus 1 is greater than 4. How does the solution change? How does the solution change? Well, since this says greater than or equal to, and that says just greater than, the solution now includes the endpoints of x is less than or equal to -6, or x is greater than or equal to 2, or 0. It now includes the endpoints. See, but here, that's just less than. So it included right next to it, but going that way and that way there. But it did not include the endpoints. It did not include the endpoints. And here it includes the endpoints. In part B, is there another way to write the solution? X is greater than -2 and x is, sure, you can put it together. It's called a compound inequality. At -2 is less than x is less than 6. And y'all have seen that before. Number 5, discussion. Suppose the graph of an absolute value function f of x lies entirely above the graph of the constant function g of x. What is the solution of the inequality f of x is greater than g of x? What is the solution of the inequality f of x is less than g of x? Okay, so for f of x is greater than g of x, is all real numbers. All real numbers, because every point on the graph of f of x is above the corresponding point on the graph of g of x. For f of x is less than g of x is no real numbers. There's no real numbers, because no point on the graph of f, because no point on the graph of f of x is below the corresponding point on the graph of g of x. Solve, your turn. Solve the absolute value of x plus 1 minus 4 is less than or equal to the absolute value of, or excuse me, is less than or equal to negative 2 graphically. So I guess what we need to do is let's draw us a graph here. Here's our y-axis. Here's our x-axis. And then, let's see, we've got negative 1, negative 4. So negative 1, negative 4. 1, 2, 3, 4. There's our vertex, okay? And let's see, here's our, let's draw that. I don't want to do it like that. Let's do it. Let's give it some black legs here. Let me get me some focus points here. 1, 2, 3, 4, and 1, 2, 3. All right, and let's see here. So 1, 2, 3, 4. That's 1, 2, 3, 4. All right, and then 1, 2, 3, 4. Okay, it has a slope of 1. See, A is 1 and B is 1, so it's going to have a slope of 1. And we'll just right there. And this, my graph's not perfectly symmetric here. I'm doing it. So we got, and there's our arrows. Now, let's see here. What do we got? Negative 2. Let's find negative 2. And we'll graph that. We'll do that here in gold. 1, 2, and then see if I got that right. And maybe it's a little bit higher. That's I was better off here, wasn't I? That looks a little bit flatter. All right, so that's the negative 2. So let's see here. That's the negative 2, and this is the. All right. So what do we need to do? We need to find these points. We'll find this point here and that point there. So what do we know? So it's less than or equal to. So less than or equal to. So it's going to lie between these 2 points. It's going to lie between these 2 points. And I'm thinking this one here is negative 3. So x equals negative 3. And that one there is going to be x equals 1. So it's going to lie between negative 3 and 1. All right. Explain 2. Solving absolute value inequalities algebraically. To solve an absolute value, and before we move on, let's do this in a calculator. It's neater. It's much neater. Unless you got graph paper, when you try to do a freehand like that. So we've got the absolute value of x minus 2, and then we go outside and we got minus 3. Minus 3, and then enter, and then press tab, and we're just going to put hold on, I'm doing the wrong one. Let's put negative 2 in there. All right, and then we'll press tab, and we'll go, and then what was it? It's x plus 1, so let's go make this x plus 1. Plus 1. And it's minus 4, so we'll make that minus 4. All right, and then we'll press enter. So there we go. Does that kind of match what that looks like? What I had over here, doesn't it? Let's see. Yeah, it kind of looks like what I had over there. And then uh, what about the points? Well, let's find that point there and that point there. And that would be menu 6, 4, and -3, and menu 6, 4, and 1. Okay, so I said it was between -3 and 1. There it is. All right. Glad that worked out. Solving absolute value inequalities algebraically. To solve an absolute value inequality algebraically, start by isolating the absolute value expression. When the absolute value expression is by itself on one side of the inequality, apply one of the following rules to finish solving the inequality for the variable. Number one, if the absolute value of x is greater than a, where a is a positive number, then x is less than -1, or x is greater than a. If the absolute value of x, rule number two, if the absolute value of x is less than a, where a is a positive number, then -a is less than x is less than a. So, example 2, solve the inequality algebraically, then graph the solution on a number line. So a, you can do a by yourself, and when you get back, we'll do b together. Glad you're back. Let's try b. The absolute value of x plus 4 minus 10 is less than or equal to -2. So we have the absolute value of, what do they do first? Well, they add 10 to both sides. So let's add 10 and add 10. And we have the absolute value of x is less than or equal to 8. So you're going to have case 1, which is just how it is, and then case 2, the opposite. So x plus 4 is, notice how, well, this case 1 is the opposite, -8, and then +8. So let's call this case 1. That's the way I always do it. And then case 2 is the opposite. All right, so subtract 4 from both sides. You got -12, subtract 4, and you got 4. So the solution is x is greater than or equal to -12, or x is less than 4. So you could write it as -12 is less than or equal to x is less than or equal to 4. So let's find -12 and 4 and connect them. All right, it's all those numbers there. And this is an and. If you look over here, that's an or. See, you got the or. All right. Reflect. In part A, suppose the inequality were 4 minus x. The absolute value of 4 minus x plus 15 is greater than 14 instead of greater than 21. How would the solution change? Well, let's see. You got the absolute value of 4 minus x, and then if we subtract 15 from both sides, if we subtract 15, you got is greater than -1. At this point, you can stop solving because the absolute value of every number is greater than -1. So the solution would be all real numbers. Okay, so let's see, how do we write this? The absolute value of every number is greater than -1. So the solution real numbers. Is the absolute value always greater than -1? Well, because absolute value is always a positive number. So it is always greater than -1. In part B, suppose the inequality where the absolute value of x plus 4 minus 10 is less than or equal to -1 instead of less than or equal to -2. How would that solution change? How would that solution change? Well, let's see here. What do we got? We've got the absolute value of x plus 4. Let's add 10 to both sides. We would have the absolute value is less than -1. It's less than -1. Well, again, you can stop because there are no real numbers whose absolute value is less than or equal to -1. Okay? You can stop. Let's see. Let's see. There are no real numbers whose absolute value I didn't spell it right. Absolute value is less than or equal to -1. So there is no solution. So this one here was all real numbers, and this one here is no solution. Your turn. Solve the inequality algebraically. Graph the solution on the number line. So let's solve it. What do we need to do first? Let's divide both sides by 3. And we've got the absolute value of x minus 7 is greater than or equal to 3. So case 1 is how it is. X minus 7 is greater than or equal to 3. Case 2 is the opposite. X minus 7 is less than or equal to -3. Notice the inequality, I swapped it around. So we're going to add 7 to both sides, and we got x is greater than or equal to 10. Add 7 to both sides, and we got x is less than or equal to 4. So it's greater than 10, it's less than 4. So let's here, less than 4, greater than 10, and we call this an OR. Okay, it must one condition or the other. Now what about this one over here? So case 1, the absolute value, well, let's see, 2x plus 3 is less than 5, and case 2, 2x plus 3 is greater than 5. So we're going to subtract 3 from both sides, and we got 2x is less, that's 2, right? 5 minus 3 is 2. Divide both sides by 2, and you got less than 1. Now, what about this over here? This is -5. So we're going to subtract 3 from both sides, and we got 2x is greater than -8. And then we divide both sides by 2, we got x is greater than -4. So let's find -4 here and +1, and it's between those two. And this is an and. And you can rewrite this, -4 is less than x is less than 1. All right. Explain 3, solving a real-world problem with absolute value inequalities. Absolute value inequalities are often used to model real-world situations involving a margin of error or tolerance. Tolerance is the allowable amount of variation in a quantity. Example 3, a machine at a lumber mill cuts boards that are 3.25 meters long. it is acceptable for the length to differ from this value by at most 0.02 meters. Write and solve an absolute value inequality to find the range of acceptable lengths. Analyze information. Identify the important components. The boards are being cut. 3.25 meters long. The lengths can differ by at most 0.02 meters. Let the length of the board be L. Since the sign of the difference between L and 3.25 doesn't matter, take the absolute value of the difference. Since the absolute value of the difference can be at most 0.02, the inequality that models the situation is the absolute value of L minus 3.25 is less than or equal to 0.02. Okay, solve. So now you got, let's see, case 2 and case 1. All right, case 1, L minus 3.25 is less than or equal to 2. So we're going to add 3.25 to both sides. So we have 3.27. Add to both sides and you end up with 3.23. So the range of acceptable length is 3.23 is less than or equal to X is less, or L is less than or equal to 3.27. All right. Looking good. Looking good. Well, let's see, justify and evaluate. The bounds of the range are positive and close to 3.25. So this is a reasonable answer, 3.25. So this is the correct answer is 3.25 or 3.23 plus 0.02 equals 3.25, and 3.27 minus 0.02 equals 3.25. All right. And let's see here. We got your turn here. A box of cereal is supposed to weigh 13.8 ounces, but it's acceptable for the weight to vary as much as 0.1 ounce. Write and solve an absolute value inequality to find the range of acceptable weight. Well, have you ever bought a box of cereal and it been empty or not have what it was supposed to have? Would that be kind of aggravating? You got up in the morning and eat your cereal and there wasn't any cereal in it. All right, so what do we got? Well, let's let W equal the weight, picking a variable that might have some meaning to it, and then we'll say the absolute value of W minus 13.8, and it doesn't matter whether you use minus or plus, is less than or equal to 0.1. Okay, so case one, W minus 13.8 is less than or equal to 0.1. Case 2, we've got W minus 13.8 is greater than or equal to 0.1. The opposite sign, and that's greater than negative 0.1. All right. Now add 13.8 to both sides and you get W is less than or equal to, and I'm getting 13.9. Over here, add 13.8. That's, like I said, that's negative 0.1. So you got W is greater than or equal to 13.7. So your box of cereal should weigh somewhere between 13.7 and 13.9 ounces. Elaborate. Describe the value of x that satisfy the inequalities. The absolute value of x is less than a, and the absolute value of x is greater than a, where a is a positive constant. Well, if the absolute value of x is less than a, the solutions of the value are between negative a and a. Let's say so. For absolute value of x is less than a, the solutions are values uh, of x between negative a, between negative a and a. For the absolute value of x is greater than a, the solutions of the value are beyond negative a and a. The solutions are values of x beyond negative a and a. So they're outside of that. They would be, in other words, less than negative a or greater than a. How do you algebraically solve an absolute value inequality? Quickly. First, isolate the absolute value expression. Okay, then rewrite the inequality. So you want to get the absolute value of x plus a, and we'll just use equals. Well, it says inequality, so we'll say it could be less than or greater than some number k. Okay, you want to get it in this form here. What's inside? Just the absolute value on one side and everything else on the right. Then rewrite the inequality as a compound inequality. That uses either and or and that does not involve absolute value. In other words, case one and case two. And then finish solving for the variable. Finish solving. 14. Explain why the solution, the absolute value of x is greater than a, is all real numbers if a is a negative number. Well, since the absolute value of any number is always non-negative, it is always greater than any negative number. That's not looking real good. Number. So all real numbers satisfy the inequality. Essential question: how do you solve an absolute value inequality graphically? I would use a calculator, but you want to treat each side of the inequality as a function and graph the two functions. Treat each side of the inequality as a function and graph the two functions. Use the inequalities symbol to determine the intervals on the x-axis where one graph lies above or below the other. Great job, folks. Have a wonderful evening, and I will see you tomorrow in class.